Okay, we're back, and we're going to start looking into the experimental literature on the poverty of the stimulus, right? And so, in the previous lecture, we talked about some poverty of the stimulus examples, and they all have this flavor where we have a simple empiricist theory of learning that children learn the syntax of their language from their linguistic input or their primary linguistic data, and so things are said around them and they learn those things. Some words tend to occur together, they form coherent units. Children learn that. They rely on their domain general learning capacity, tracking probabilities of things occurring together, and bootstrapping or inferring some notion of constituency from that. And it's a nice, neat learning theory where you speak a language around a child and the child learns the language without any special innate mechanisms. And the flavor of the poverty of the stimulus argument is that this theory can't work. Why? Because there are some things that every mature speaker of a language knows implicitly about the syntax of their language, but that can't be learned from the kinds of evidence or the kinds of linguistic input that children get when they're young. So we looked at a bunch of cases of this type in the last set of slides. And all of those cases so far have just had the nature of sort of informal observations. We find a set of facts that are sort of interesting and intricate and complex in sort of adult final state English grammar. And we note that, well, every adult English speaker seems to know these things about their grammar. How could they have learned that? Because I can't imagine that kids get much exposure to things like this. That's the flavor of all of these. And of course, ideally, you'd want to have a little bit more detailed, rigorous evidence about what children get exposed to and how they learn things and by what age they learn things. And so we're going to go in kind of levels here. So first, we're going to look at trying to confirm that children do indeed learn these things and how they learn them and what kinds of stages they go through. Later on, we're going to start trying to look in a little bit more detail. We'll see criticisms of these examples, and we'll try to look in a little bit more detail at what kinds of actual evidence children really get in child-directed speech, but we're going to go in levels. So we're going to try to test sort of one thing at a time by going into some more experimental kinds of laboratory conditions. So we started, or not we started, but last time we looked at this argument about structure dependence, and many of the most convincing poverty of the stimulus examples involve this property of structure dependence. So what did that mean? Well, we were looking at when a pronoun like himself or his or he is allowed to refer to the same entity as a full noun phrase or an R expression like the lion. And we saw that there's these sort of simple examples. The lion will groom himself, no problem, having co-reference here. The lion will groom his fur, no problem, having co-reference here. He will groom the lion, problem. You can't have co-reference here between he and the lion. And so for these simple examples, the principle is quite obvious. It's just that the R expression has to come first and the pronominal element has to come second in the sentence. Here, the pronominal element comes first and the lion, the R expression comes second, so you can't have co-reference. And this extends to many more complicated constructions as well. So here's a sentence with an embedded clause. We don't think children hear a ton of these, but maybe they're going to hear some of them. And that principle still works. He saw when the lion was in the box, and that's you can't have co-reference between he and the lion here. It has to be two different individuals. So our theory where the R expression has to come first in order to co-refer the pronoun, that still works for this example. We could also switch these. The lion saw when he was in the box, and that's also no problem here. You can have co-reference. Right? It's a slightly strange meaning in that particular case, but there's no problem with co-reference here. So this is the simple structure-independent theory of how our expressions are governed, or the co-reference of our expressions and pronouns. This is referred to in the syntactic literature as principle C of the binding theory, where the binding theory deals more generally with co-reference amongst different things. Right? So simple theory, linear precedence is what's at work here. That's structure independent. And if this is the kinds of data that children get, you'd expect them to learn that generalization. Um, and there will come a point in their lives when they start getting exposed to some more complicated kinds of utterances, and this will turn out to be wrong, right? So the so-called backwards binding phenomenon here. When he was here, the lion was angry. Right? This is a case where the pronoun he precedes the R expression the lion, yet there's no problem having them co-refer. And every native speaker of English agrees that this is perfectly fine with co-reference. Right? So it turns out that linear order theory was wrong, and what we need is a much, much, much more complicated theory of how this co-reference works. And what the right principle is, the structure dependent one, is that an R expression must not be C commanded by a co-referent pronoun. And C command here is a very complex structural notion, or it's not that complex a notion, but it's a structural notion that operates over extremely complex hierarchical syntactic structures that we often represent in writing with these trees because it makes things visually easy to understand. C command is a particular relationship between a node and the syntax, like here's the noun phrase the lion, and we say that this noun phrase C commands its sister and everything dominated by the sister. Right? So here in this particular case, even though the pronoun he precedes the lion, the pronoun he does not C command the lion. It only C commands the stuff underneath this IP node. Therefore, co-reference is fine here because principle C is satisfied. An R expression, the lion, must not be C commanded by a co-referent pronoun, he. And here, this is not C commanded by that, so co-reference is fine. The linear order theory would predict that you shouldn't be allowed to have co-reference here and would be wrong. Yet all native speakers of English, at least by the time they're adults, recognize that co-reference here is fine. The question is, how could they have learned that? Because we're assuming that young children are not being exposed to lots of these structurally complex backwards binding expressions. These are not very common in actual English speech. So if they're mostly getting examples like 1, 2, and 3 here, the simple ones, and even if they're getting some complex examples like 4 here, children ought to learn the structure independent generalization, yet it doesn't appear that they do. Therefore, the claim goes, there must be some sort of an innate learning bias for structure-dependent generalizations like principle C instead of structure-independent generalizations like the linear order one. And in fact, it's been claimed that this is a universal part of universal grammar for all syntactic generalizations. If you have either a structure-independent or a structure-dependent generalization available to you as a learner, you always choose the structure dependent generalization because that's simply the way that your grammar is set up. It's not built to find generalizations over linear order. It's only built to find generalizations over complex hierarchical structure. So that's the importance of the principle C example. And for this one, there's not a huge experimental literature in this, I don't think, although there is a paper from the 1980s that shows that most 3-year-olds have no trouble understanding and accepting backwards binding examples. So by the time they're 3 years old, English learning children have mastered these facts, right? So in order to have learned them, they would need to have these complicated structures in their linguistic input during the first 3 years of life, and that seems kind of implausible. Right? Later on in this unit, we'll get to actually trying to examine that more directly, but for now, we're just going to note that we don't think children are getting exposed to lots of sentences like this, and certainly they're going to be exposed to many more sentences like these simple ones, the first 3 here, and there's going to be lots and lots and lots of these simple ones, very few of these super complicated ones. And so it's not clear how children would ever learn this from evidence unless they had some sort of a pre-existing bias. Here's a very similar example where Crain and Nakayama did a real experiment with real children to try to figure out exactly what's going on. Well, not exactly what's going on, but some of what's going on in the learning process. It's going to be very similar to the Principle C example, but it's a different phenomenon in English grammar. And this is sort of indicative of how syntactic generalizations tend to work across lots of languages. Every language, has a different set of transformations and relationships between sentences and facts like that. But all of them basically seem to be dependent on structure in some way. At least that's the Chomskyan claim. And so this is a different English example that involves a totally different set of phenomena, but is also going to end up having some structural elements to it. This one is referred to in the literature as auxiliary fronting, right? And it's about how you form yes/no questions from corresponding declarative statements. Here's the general form of the argument before I tell you what the auxiliary fronting is about. Here, it's going to be exactly like the Principle C argument we just went through. So children are going to encounter lots of simple cases earlier, and presumably more frequently than the really complex syntactic constructions. That's going to be in their primary linguistic data, their linguistic input. The simple cases that they're getting exposed to a lot are consistent with either a structure-dependent generalization or a structure-independent generalization. The structure-independent generalization is going to be much simpler. We saw that in the Principle C example. So if children don't entertain that structure-independent rule, there must be a bias towards structure dependence, because why would you pick a more complicated generalization when there's a much simpler one available? Well, the UG hypothesis says actually the simpler one isn't really available. That's why you end up with the more complicated one. Here, Crain and Nakayama are going to try to show directly that children don't entertain the structure-independent rule, and they're going to conclude, therefore, that there is a bias towards structure-dependent rules. So here's the phenomenon that we're talking about, the auxiliary fronting. And it has to do with patterns of relationships between different kinds of sentences, right? So this is a really important kind of evidence that gets used in generative linguistics. What we know when we know English is not just the strings of words that constitute well-formed sentences in English, but also relationships between different kinds of sentences. And in particular, every native speaker of English knows that there's a relationship between declaratives and yes/no questions, such that it's possible to create out of any declarative sentence, more or less. There's probably some exceptions, but out of most declarative sentences, there's a way to create a yes/no question corresponding to that declarative. So if I give you the string of words, "the man is in the other room," and ask you to make a yes/no question out of it, every native English speaker can transform that into, "is the man in the other room?" And so the way we talk about these relationships is in terms of syntactic movement. And that is just a metaphor. We're not necessarily claiming that people are literally moving words around in their heads. But when you look at the relationship between these two, you can think about it in terms of the metaphor of movement. You start out with this basic declarative. The auxiliary verb here is, right, is in a particular linear position. Then when you turn it into a yes/no question, it's no longer in that position. And for written representations, again, we'll put this thing trace here, which is just meant to indicate that in the original there was a word here, but it's gone now. And instead, that word shows up here at the front of the sentence, at the beginning of the sentence. Similarly, this is true of all auxiliaries and modals in English. Eagles can swim, turn that into a question. Can eagles swim? Where again, can started here, but it ends up here. Or it was here in the original sentence, but is no longer there. It's now here. So we call that syntactic movement. And this is basically how yes/no questions work in English. When you have an auxiliary in the original sentence, works a little bit differently when you don't have an auxiliary, but we're going to ignore that for the moment. So yeah, question is, what's the rule here? What's the generalization? And again, just like with Principle C, I've written these out first with no complicated syntactic structure, just numbers indicating what order the words come in. And so the easy solution to this, the thing that you ought to learn if you're being a sort of efficient and rapid learner, is just related to linear order. What do you do here? Take a moment and see if you can think of the simple structure-independent generalization that governs simple examples like this. Okay, did you get it? What's the structure-independent rule that you could use to deal with these primary linguistic data? Here's Crain and Nakayama's version of it. In yes-no questions, the leftmost verbal element of a declarative, is, can, etc., has been moved to the front of the sentence, right? Simple. Look at the original declarative, find the first verbal element, the verbal element, nope. Man, verbal element, nope. Is, verbal element, yes. Number 3 here. Move it to the front of the sentence. Make it number 1. Is the man in the other room? Perfect. Solve the problem. Same thing here. First verbal element, can. Move it to the front of the sentence. Make your question. No complicated syntactic structure necessary. This is, again, a simple generalization over the order of words in a sentence. And just like in the principle C case, let's look at a more complicated example here. What about sentences that have more than one auxiliary verb? Well, here's an example. This is more complex now. We wouldn't expect kids to get exposed to too many of these because these are really complicated sentences. But let's see if this simple linear structure independent generalization still works here. Here's the declarative. The man had thought that John had come. And here we have 2 auxiliary verbs here. Let's see if our generalization still works. The leftmost verbal element, or the first one, the verbal element, nope. Man, verbal element, nope. Had, verbal element, yes. It's the first one. Move it to the front of the sentence. What will you get out of that? You'll get had the man, trace, thought that John had come. Had the man thought that John had come? And that is indeed the correct question. So our really simple structure-independent generalization here is working out. It's even generalizing to some more complicated sentences with, these are sometimes called psych verbs, with embedded clauses, with multiple auxiliaries. So we're doing great here, and this is super easy to learn. Just like with Principle C, though, eventually we're going to run into some complicated structural configurations where this rule fails. Right? And so in particular, check out these sentences. The man who is tall is in the other room. Now, our simple linear structure-independent hypothesis would say, find that first verbal element, move it to the front of the sentence. What would that result in? Is the man who tall is in the other room? Ungrammatical. Instead, in this one, it's the second verbal auxiliary that moves to the front of the sentence. And you get number 6 absent here. Is the man who is tall in the other room? That's the actual well-formed question where you've moved this one to the front and not this one. Similarly, eagles that can fly can swim. Here, if you take this strategy of taking the first verbal element and moving it to the front, you would get, can eagles that fly can swim? And that's ungrammatical in English. Instead, you have to move the second modal here. Can eagles that can fly swim? So our simple linear structure-independent generalization, again, turns out to be wrong here. But in order to know that, you would need to be exposed to some super complicated kinds of constructions here. So these are, in particular, both of these sentences are sentences with subject-relative clauses and a second verbal auxiliary after those relative clauses that have been transformed into yes-no questions. So again here, the intuition is going to be young children are virtually never going to be exposed to things like this in their linguistic input. And we'll see some justification for that later in this unit. But that's just at a first pass. Chomsky sort of looks at these and says, well, no kid is going to get exposed to this input. They're going to get exposed to maybe some of these, right? And maybe a few of these more complicated ones. But this one, children are never going to be exposed to this. Yet by the time we're adult native speakers of English, every single native speaker of English knows that you move the second auxiliary here. There's no doubts about that. That's completely categorical and obvious. Moving the first one is completely ungrammatical and impossible. Right? So we all end up very clearly having implicit knowledge of this phenomenon. And the question is, how on earth could we have learned this without getting exposed to lots of yes no questions that extract an auxiliary across a subject relative clause with another auxiliary in it? Right? That's not something that's going to happen a lot. What's the real solution here? Well, this is close to the real solution. This is Crain Nakayama's hypothesis too. In yes-no questions, the auxiliary verb in the main clause of a declarative is inverted with the subject noun phrase. This is the correct generalization. At least it's very close to the correct generalization, right? So the man is in the other room. This is the simple example again. And here the structure independent generalization would do just fine. Take the first auxiliary and front it. But also there's this structure dependent alternative. Find the main clause. Well, this one only has one clause. Find the auxiliary in the main clause. It's going to be is. And change it around with the subject noun phrase, the man here. So that's exactly what we get. Change around is and the man, you get the same answer here. So both kinds of generalizations work. Similarly, for eagles can swim, only one clause, find the auxiliary, switch it around with the subject noun phrase eagles. Can eagles swim? Great. So this is going to work for the simple examples. It's, again, a much more complicated kind of generalization than the structure independent one. Why is that? Because this notion main clause that's in the statement of the solution here, that can only be defined with regard to hierarchical syntactic structure. Arguably, actually, the same thing is going to be true for the notion subject-noun phrase, that also we need to have reference to this in the correct statement of the rule. We're going to focus less on that, but it's for sure the case that the notion main clause is a notion that you can only define if you have complicated hierarchical syntactic structure. So how does this work? Again, simple examples. We started here with the generalization that find the first verb and move it to the beginning of the sentence. Really simple. This is much less simple. We have a hierarchical syntactic structure here, again represented visually with these tree diagrams. And here we're going to find the main clause, and a main clause here is going to correspond to the inflectional phrase, this IP here. And we're going to find that main clause and find the inflectional element in it. So here it's is, here it's can. And then we're going to invert that with the subject noun phrase. And the subject noun phrase is going to be the highest thing that's attached inside the sentence, the IP here. So how are we going to do that inversion? Well, I've put some higher structure up here just to indicate that we think these questions have some sort of extra hierarchical structure, and the auxiliaries here, is and can, in the question versions, when this is a question phrase, these are going to be higher up in the tree, somewhere inside this question phrase, but outside of the IP. And the true story about what's happening with subjects and auxiliaries in English questions is probably a little bit more complicated than this, but for our current purposes, this is going to be a perfectly sufficient theory of yes-no question formation. Find the main clause auxiliary, main clause auxiliary, and invert it with the subject noun phrase. Subject noun phrase. How are you going to do that? Well, there's some extra syntactic positions up here somewhere that you can maybe move the auxiliary into. Right? That's the basic idea. Super complicated, not simple like our linear order solution. And for these simple sentences here, it makes exactly the same predictions, so we should clearly prefer the structure independent generalization. Here's the more complicated structure. The man had thought that John had come, with an embedded clause, an embedded CP and IP here, that John had come. It's like a second sentence. And our both generalizations still work here. So find the first verbal element and move it to the front of the sentence. That will work. Had the man thought that John had come? But also the structure dependent one will work. So find the main clause. Well, here it's important to know that one of these clauses, the IP here, dominates the other clause, the CP and the IP down here. That means that this is the main, or it's sometimes called matrix clause. And this clause down here is the embedded clause. And what we want is the main clause. Now find that main clause's inflectional element, right? This is the inflectional element that heads this inflectional phrase, had, and invert this with the matrix subject noun phrase, right? Again, this is the main clause subject, the man, not the embedded clause subject, John. So you need to have hierarchical syntactic structure in order to do things like main clause and main clause subject. Right? So obviously, hypothesis 2 here is much, much more complicated. What do we get for having this super complicated generalization? Well, here's the payoff. Right? In these examples, the man who is tall is in the other room. Interestingly, here, the main clause auxiliary is the second auxiliary. It's this is here. It's not the is that occurs first in the sentence. This one is embedded inside a relative clause. That's an embedded clause, not the main clause or the matrix clause. Therefore, here, the rule that says move the first auxiliary to the front of the sentence is going to pick out this one. And the rule that says find the main clause, find its head, move that inflectional head, invert it with the entire subject noun phrase, that's going to get it right. So that's going to predict we ought to move this one. The linear order theory says we should move this one, and it turns out that this structure-dependent alternative is right. This is what English speakers end up knowing, and not this. So categorically, all native speakers of English reject the sentence or the question, is the man who tall is in the other room? That's impossible. Here it is again with the eagles that can fly can swim. Here again, the first auxiliary is this modal can, which is embedded inside a relative clause. But the main clause auxiliary is corresponding to this inflectional phrase up here is the second modal can. And so the structure-dependent rule says move this guy. The structure-independent rule says move this guy. And English speakers with mature grammars all have learned the structure-dependent rule and not the structure-independent one. So this is why we think the structure-dependent alternative is what people settle on. That's what we end up having. And the question is, how on earth could we do that without being exposed to tons of these really complicated structures? Here's the way Crain and Nakayama phrase this. It seems reasonable to suppose that children encounter the simpler forms first. Since the structure-independent operation appears to be computationally simpler than hypothesis 2, which is the structure-dependent one. And since it's consistent with this subset of primary linguistic data, one might suppose that at least some children entertain hypothesis 1, the structure-independent one, during grammatical development, contrary to the claims of universal grammar. So universal grammar claims instead that children only ever entertain the structure-dependent generalizations, even though there's a much simpler structure-independent one that matches basically all the data they're going to see. These children would produce ungrammatical questions like 7, and this is the example that I just gave that's impossible, where you extract the auxiliary from a subject-relative clause, when they first attempt to form yes-no questions with complex subject-noun phrases. So the idea here is, well, a sensible learner that's going to be exposed almost entirely to examples like this, the simple examples, and not to the super complicated examples. Under those conditions, a sensible learner would learn the structure-independent generalization, and if children are sensible in this particular way, then they ought to at least try the structure-independent generalization. So when they first start learning about these more complicated structures with subject-relative clauses, then they ought to make mistakes, right, if they're entertaining that structure-independent generalization. So let's check that out. Do children actually go through a phase of trying out the structure-independent possibility and then somehow learn that that's wrong? Well, how would we test that? In general, it is the case that children go through lots of phases of getting things wrong before they settle on a mature grammar. So here's Crain and Nakayama again. When misgeneralizations do occur, they apparently reside in children's grammars for some time before they're abandoned in favor of correct generalizations. For example, Overgeneration of causative verbs, example here is who deaded my kitty cat, has been observed to begin at age 3 and to continue until age 7. Sorry, there's a typo there. There's some reason to expect then that pure syntactic misgeneralizations would also persist through early childhood if they arose. Right? So what they're pointing out here is that kids make all kinds of mistakes, or they learn all sorts of generalizations that are not actually part of the adult grammar. And when they do that, they tend to keep those wrong generalizations for a while. They persist in time. Kids don't just get corrected once and change their grammars. They have these, they're calling them misgeneralizations or overgeneralizations that last for a long time. So if they're going through a phase of preferring the structure-independent rule as a sensible, computationally efficient learner should do, then we would expect those errors to persist in their grammar for some time. And let's investigate that. Let's get some kids in the lab and see if there's any evidence for this kind of misgeneralization in this auxiliary fronting domain. How are we going to do this? Well, this is ingenious. The experimental task had each child pose questions to a doll. The doll is Jabba the Hutt, who's from Star Wars. And the doll was manipulated by one of the experimenters. The other experimenter directed the child to ask Jabba particular questions about a set of pictures, which were then shown to Jabba. After each elicited question, Jabba was made to respond yes or no. Whenever a question evoked an appropriate response from Jabba, the child pretended to feed Jabba. All the children were enthusiastic participants in this game. It's fun. It's a fun game. You get to boss around a bad guy from Star Wars. Why is this ingenious? Well, here's the thing. When you tell somebody to ask Jabba a question, the question is going to be embedded in that sentence. And when the question is embedded, it doesn't have auxiliary fronting in it. It's going to have the corresponding declarative of the type that we've been looking at in all these examples, right? So the experimenter's embedded questions are going to be something like, ask Jabba if declarative, right? So if the question here is something like, the boy who is happy can see Mickey Mouse, this is, again, a complex sentence with a subject-relative clause and with two auxiliaries in it. And in forming the question, you're going to need to move one of those auxiliaries. But the experimenter here is embedding that question under this predicate ask Jabba if, and that means that the auxiliary fronting is not present in what the experimenter says. The experimenter is going to say, ask Jabba if the boy who is happy can see Mickey Mouse. Right? So there's no auxiliary movement in that because it's not a full question yet. It's an embedded question. When the child responds to that, they're going to have to produce a question, and we're going to see what kinds of auxiliary movements they do. So really ingenious design here. Let's check this out. What do they find? Here's experiment 1. And they've split the kids into two groups. A younger group, I think these kids are about 3 to 4.5 years old. And an older group, group 2, these kids are 4.5 to 6 years old. And here's what they're finding. This younger group is definitely still learning how to form yes/no questions. They're correct. They get the correct answer here less than half the time. So the correct response to the example I gave, ask Jabba if the boy who is happy can see Mickey Mouse. The correct answer there would be, hey, can the boy who is happy see Mickey Mouse? Children in this first group only get that about 40% of the time. By the time they're 4.5 to 6 years old, they're getting it much more often. And so in general, there's evidence that they're going through a stage of figuring out how these complex questions work. They're not quite there yet. There's a number of ungrammatical questions in both age groups, more for the younger age group than the older one. But in general, both of them are making lots of mistakes here. And the next question is going to be, well, what kinds of mistakes are they making? And in particular, are they making the mistake of picking the first auxiliary according to our structure-independent simple generalization and fronting that to the beginning of the sentence? Right? If they're entertaining that structure-independent generalization, this is the mistake that they should be making. Right? So are they? That's the question. Well, they've split the errors here into 3 different types. Type 1 is an error where they just leave all the auxiliaries in place. and also add another one at the beginning of the sentence. So would correspond to ask Jabba if the boy who, so these all have the same auxiliary twice. So let me try to come up with a slightly different example here. Ask Jabba if the boy who is tall is in the hallway. A type 1 error here would be, is the boy who is tall is in the hallway? So that's the most frequent kind of error that these children are making. And it's not exactly clear what's going on there. There's an extra auxiliary that's been copied somehow. There's certainly no evidence that they've removed the first auxiliary from inside the subject-relative clause. It's still sitting inside there. Type 2 errors are what they refer to as a restart error. And this is basically where kids can't quite figure out how to make the question, and they sort of start it and then finish it in a separate sentence. So the example they give here would be something like, is the boy who is tall, is he in the hallway? That's actually, that's not even really ungrammatical. That would be a perfectly normal thing to say in everyday spoken English. But again, it involves this extra auxiliary that shouldn't be there, quote unquote, in the correct version. Again, they're not obviously taking the auxiliary out of the subject-relative clause. That auxiliary is still sitting inside that subject-relative clause. And so this is almost all of the errors that get made in the experiment. There's a whole bunch of other sort of random errors where they just say something totally ungrammatical. Importantly, type 3 errors here are errors where children take the first auxiliary from inside the embedded subject-relative clause and move it to the front of the sentence. This is the one that the structure-independent generalization should create. There are 0 instances of type 3 errors in this experiment. No child in the experiment ever makes this mistake, despite the clear fact that they don't know exactly how to make these questions yet. This is not a mistake that they apparently ever make. So that is striking. That said, there's still some sort of follow-up questions that need to be addressed. I'm going to briefly go through a few of these because they're nice illustrations of how you do an experiment, you have some interpretation of your results, but then other questions arise and you want to try to really take care of all the loose ends and try to address all the possible objections or criticisms. So this is the most frequent error by far, copying the auxiliary verb. Is the man who is tall is in the room? And this is ungrammatical in adult English. So one problem that arises here immediately, so somebody who maybe doesn't believe in this poverty of the stimulus argument could look at this and say, well, this is exactly the structure-independent error. They're taking this is and they're copying it from inside the auxiliary, the relative clause. They're copying that first auxiliary, even though it's embedded, and they're putting it at the front of the sentence. Maybe that's what's going on here. So experiment 2 is going to try to disambiguate whether when you get these errors, is this thing here going to be a copy of the first auxiliary, or is it going to be a copy of the main clause auxiliary? And how are they going to do that? They're going to turn them into different auxiliaries. Ask Jabba if the man who can talk is in the room. Now, if the child produces an extra auxiliary here, we're going to see whether it's can, in which case it matches the embedded auxiliary, or is, in which case it matches the main clause auxiliary. So the results of this experiment are not entirely clear to me. There's a whole bunch of weird things going on in the experiment, but one thing that comes out clearly is children are not necessarily copying this first auxiliary, or very rarely are. It doesn't look like. So it seems to confirm that indeed they're not making this kind of structure-independent error. And then there's a third experiment here that's addressing yet another confound or another problem that you might find with this experiment. And this one has to do with meaning or with semantics. And so here's the observation. When you do this question formation in the simple cases, the man is tall. Is the man tall? This part that you're stranding back here after moving the auxiliary is a coherent phrase that means something. The man has a definite referent, right? It's clear what this means. Similarly, eagles can fly. When you create can eagles fly, the thing that you're moving across, the thing that you strand here, is a coherent noun phrase that means something. Eagles. In these more complicated subject relative clause examples, these have a very different character. If you move the first auxiliary here, is the man who tall is whatever, the thing that you're stranding is the sequence the man who. And this is not a clear, coherent phrase with a clear, coherent meaning. This is like an incomplete meaning. It's a linguistic element that doesn't seem to correspond straightforwardly to any meaning. Similarly, if you move the first auxiliary here, you get can eagles that fly can. You're stranding eagles that. And again, this is not a set of words or a phrase that has a clear, coherent meaning, a semantic value. So maybe, oh, and important to note here, when you move the main clause auxiliary, as the adult generalization, that's how it works, is the man who is tall. The thing that you strand here, the man who is tall, again, this has a clear semantic meaning. Right? There's a referent or a set of reference for the man who is tall. Similarly here, you move the main clause auxiliary, you strand eagles that can fly, and again, that's like a complete semantic thought, right? It's something with a clear meaning. So one possible objection to the experiment, right, is that, well, what kids have learned is not anything about main clause auxiliaries and main clause subject noun phrases and complicated hierarchical structure. It's just that when you're going to move an auxiliary, you have to leave behind something that's a coherent, meaningful phrase. Maybe that's what we're finding here. Maybe that's how kids learn this. It's not really about the syntax at all. So they're going to try to rule this out in experiment 3 using so-called expletive subjects. What does that mean? Well, in English, you get certain instances of these pronominal forms or demonstrative forms, it and there, that carry no meaning. Right? And this would be true in a sentence like, it is time to go home. Right? So here, what is the it in subject position referring to? Nothing really. It's just filling a syntactic slot because English sentences have to have subjects. Right? When you question this, you get, is it time to go home? And the thing that you've stranded is it. And just like in these examples, with the man who or eagles that, this is not a complete semantic entity because it doesn't refer to anything. So if kids are just learning that the thing that gets stranded or that gets moved around has to be a coherent semantic entity, they should not be able to do these ones either because the expletive it here is not a coherent semantic entity. So what happens if you do this? It turns out kids are even better at these ones than they are at the more complicated examples in the first experiment, right? Which is sort of unsurprising when you think about it. And so there's far fewer errors here. Almost all of these are correct. And so what's interesting here is that apparently the thing that kids are learning is not that you have to leave behind a subject that denotes a coherent semantic entity. That's not what they're learning from their data here. They are untroubled by stranded or left behind or moved around subjects that don't denote coherent semantic entities. So Crain and Nakayama from all of these conclude that, in fact, there is no evidence that 3 to 6-year-old children entertain the incorrect structure-independent generalization about auxiliary fronting. There were literally 0 instances of them making those types of errors. Right? So children just don't seem to be going through a phase of grammar where they incorrectly thought that the first auxiliary had to be moved, even though that theory is much, much simpler than the correct structure-dependent one. And they haven't completely learned the structure-dependent generalization at this age. They're still making lots of errors. They're just not the errors that would implicate the structure-independent generalization. And this is true despite the fact that presumably they've seen a lot more primary linguistic data that's consistent with both hypotheses, that is the simple examples we started with, than they have PLD consistent only with the structure-dependent rule. That's going to be the complicated subject relative clause examples. We presume that they haven't seen or heard that many of those examples, and they've heard a lot more of the simple ones, yet there's still no sign whatsoever that they're even thinking about the structure-independent generalization. Therefore, they must have an inherent or innate bias towards the structure-dependent generalization. That's the conclusions of the study. So I've put down this parenthetical here, what's missing from this study. And I'll just tell you, I think the suggestion here is that this word ostensibly is going to be important here, right? So the claim here is that just intuitively thinking about the situation, we assume that kids really are not getting lots of yes no questions over subject relative clauses that contain an auxiliary verb. But nobody has conclusively demonstrated that yet, right? So that's what I would say is the missing part of the argument. We've gotten further now than our initial informal observations, but we still haven't quite provided that killer evidence that children have to be doing this with an innate bias. So we'll look at that in the following weeks, depending on how much time we have in the semester. There's another another poverty of the stimulus example I wanted to briefly go through here that involves phonology. I'm going to split this out into a separate bonus mini lecture that's going to have a lot of swearing in it because this is an example about swearing in English, but I'll split that into a separate lecture.